I'm Richard C. I'm a math tutor here at Wyzant, answering a student question that came into us. We want to find the inverse of this function g, so let me just, instead of g, I'm just going to write y here and just copy this out. So y is equal to x squared minus 2x. And I think it's a good idea to have some sense of what the graph of this looks like. And you can plug in points, or you can put it in your calculator, or you can go on to Desmos or something and figure it out. Or we can graph this by hand just by writing this as x times x minus 2. So we know the intercepts are at 0 and at 2. And we know the vertex is at 1. When you plug 1 in for x, you're going to get negative 1. So here's a negative 1. So here's our vertex, and here are some points here. Okay, so let's go about our business and get the inverse, and then we'll come back and look at domain and range, because we have to take note of the fact that the original function, the domain, is restricted. So we want to reflect that restriction in the inverse as well. So I'll just change colors. We're going to just swap the x and the y, so you're going to get that x is going to be equal to y squared minus 2y. Now, the trick here is we need to isolate the y. We need to solve for y. We're going to do that by completing the square. Notice that b is negative 2. So the formula we use is b over 2 quantity squared. And this is for completing the square. If you don't know how to complete the square, you should look that up elsewhere. So this could be negative 2 over 2 squared. So this is 1. So now we can write x plus 1. Sorry about that. X plus 1. There we go. X plus 1 is equal to y squared minus 2y plus 1. And now we'll factor that. So x plus 1 is equal to y minus 1 quantity squared. Okay. And then we'll take the square root. So square root here, x plus 1. And so our final answer is y is equal to 1 plus or minus the square root of x plus 1. And that's our f, as we'll call this g inverse of x. So let's start looking at the restraints and what that's giving us here. I'll go back to black. And oops, we're still in green. Okay, so we're saying that the domain of this is going to be x greater than or equal to 1. So you can see we're only dealing with this side, this half of a parabola, basically, from here on out. X is greater than 1. And you can see when x is 1, y is negative 1. So the range here is going to be y is greater than or equal to negative 1. We know that the domain of the original becomes the range of the inverse, and the range of the original becomes the domain of the inverse. So now here in green, switch back to green. So the domain of this thing is x greater than or equal to -1, and therefore the range is going to be y greater than or equal to 1. So that eliminates the this. We could rewrite this now because of these restrictions, we don't have to worry about the negative square root. So because you can see that the domain, because the domain is restricted to greater than 1, this function here is going to be a one-to-one function, and so its inverse will also be a one-to-one function. So we can just rewrite this as G inverse of x is equal to 1 plus the square root of x plus 1, like that. And that should do it, because you see x has to be greater than -1, which means this is a positive value. And so we put these were placed. This is part of a larger lesson from school, which has to do with what you have to do with a function that originally is not one-to-one in order to get a inverse that is an actual function. So this is a bit longer it's a longer conversation than what I'm going to be able to get into here. But I'm answering the question, and I'm giving you a little bit more information by listing out domain and range for the original function and for its inverse. So hopefully that'll answer your question, and that's it for today. I'll see you guys next time. Bye-bye.